Hello students, welcome back. In this lecture we will see problem related to parallel force system part 2. I am considering problem appeared in exam 2023 of D. Batu Lonere University. So the problem number is question number 1B. The question appeared for 6 marks. So let us have the question here. I am writing for you for more clarity. (2023) for 6 marks. The question is a beam AB of length 5 meter supported at A and B carries 2 point loads W1 and W2 of 3 kilonewton and 5 kilonewton, which are 1 meter apart. If the reaction at B is 2 kilonewton more than that at A, find the distance between the support A and the load 3 kilonewton. Right? I hope the question is clear. Dear students, this is a googly question actually. The student don't read, they see as it is a difficult question and they just left it. I will suggest you to read the question carefully, understand it to the best, and then have a diagram. Try to solve this. When it is mentioned that it is a beam, so just have a beam, then have a diagram of beam in solution first. Need not to be panic. You have to be very patient, right? So beam of 5 meter length is given and it is AB, so just name it. And when it is mentioned that it is a beam, just have a simply supported beam, right? Mention here A, B, show the distances according one by one, 5 meter. So the first line is clear. The beam AB of length 5 meter supported at A and B. So supported at A and B, 5 meter span, right? It carries a point loads W1 and W2 of 3 kilonewton and 5 kilonewtons. Now they have not mentioned where they are acting. Only they said they are 1 meter apart. And one more condition they have given, that is if the reaction at B is 2 kilonewton, it means they have given this reaction, that is RB equals to 2 kilonewton. See, read one by one, go step by step, and then you will get a better understanding how to solve this problem. So I am repeating here. So they have mentioned that if the reaction at B is 2 kilonewton more than that of, they have just put it one condition, more than that at A. It means RB will be more, okay, RB will be greater than what? RA. We are not supposed to find RA here, right? But we will get understanding that the loads are near to B. Why? Because they have mentioned that the reaction at B is 2 kilonewton more than that at A. It means the point loads which I am going to show here will be near to B. If you show anywhere in the beam, no worry. You need not to worry, but go with the better understanding, right? Understanding in mechanics is very important. So just show near to B, and that too 1 by 1, 3 kilonewton. So first load I am showing 3 kilonewton and second load is 5 kilonewton. Where they are acting from B is not known, but the distance between them, that is, they are 1 meter apart. So show 1 meter apart, right? So I hope it is clear to you, right? And let us assume that the distance from A up to 3 kilonewton is x, because it has been asked to find the distance between the support A and the load 3 kilonewton. So this is what is expected here in this problem. So we will use the principle of moments and we will get the distance x simply. And you need not to find this RA reaction here. No need, because you have one reaction with you, and if you will take the moment of all the forces, right, about A, simply you will get the distance x, right? And that is what expected here. So simply using principle of moment, right, about A point, I am going to take moment of all the forces about A point, right, with usual sign. So RB into, that is 2 kilonewton, but that I will put afterwards. So RB into perpendicular distance is 5. So RB into 5. Now this was, anti-clockwise. So equals to, now these two forces are clockwise about A. So now that's what I have put here, equal sign. So no need to write a sign now, right? So let us take a moment of 5 kilonewton. So 5 kilonewton moment about A is what? It is x plus 1. See, the total perpendicular distance up to A point from 5 kilonewton force is this x plus this 1. So 5 in bracket x plus 1, right, like this. Then moment of 3 kilonewton force, that is 3 into x. I hope it is clear. Now simply solve this. This is 5 RB is equals to, just solve this bracket. So it is 5x, 5 into x plus 5 into 1 is 5 plus 3x. Simplifying again and substituting RB here in this. So 5 into RB is given 2, that is equals to, this is 8x plus 5. I am going step by step, no need to be hurry, right? Solve step by step to avoid the mistakes. So 10, this is 5 into 20, 10. This I will take this side. So 5 minus, 10 minus 5 is equals to 8x, right? Hence x is equals to 5 divided by 8, right, meter. You can solve on calculator. So you will get x equals to 0.625 meter. So this is what expected. Hence the distance between the support A and the load 3 kilonewton is equals to 0.625 meter. This is the answer, and this is what expected is for 6 marks. I hope it is clear. So let us have one more problem related to parallel force system, which is appeared in exam 2019 of D/2 examination. So the problem is here, you can see in the question paper, appeared in 2019, right? And this is what the problem we are going to solve here. So I will have a diagram for you. D/2 exam 2019. I am purposefully mentioning the year here for your reference, so that you will be knowing for what marks and for when this question has been appeared. This question was for 4 marks, right? And let us have the problem. The problem is a uniform beam AB. Diagram is also given, right? A uniform beam AB of weight 100 Newton and 6 meter long, had 2 bodies of weight 60 Newton and 80 Newton suspended from its 2 ends as shown in figure. Figure is given, right? Find analytically at what point the beam should be supported so that it may rest horizontally. Okay, in short, we want equilibrium of the beam. It should be stable, right? And let us have the diagram for better understanding. They have given the diagram also, because in first year the students have little bit confusion about the diagrams, so they make more convenient to you to have a diagram. Otherwise it is very simple from the statement also, right? You can have see, you will understand. They have given here that 60 Newton and 80 Newton is suspended. So 60 Newton and 80 Newton, they are suspended like this, right? Then as the weight is acting at the center, it will be shown at center exactly. So the beam is of 6 meter. The distance between this 100 Newton and these suspended loads will be equal 3 meter, 3 meter. It is given in the diagram also, no need to worry. This is A point, this is B, this is C point, and they have shown a force which is in upward direction, right? And this is what we have to find. and we have to locate it in the diagram. And this is what is asked, that find analytically at what point the beam should be supported. So this is the support for the sake they have shown, and this is what is expected in this problem, and we have to find its position from B. Always keep in mind the X, wherever it is shown from the reference point, either A or B, you have to find the X from that point only. I hope it is clear. So let us have the problem solution. Now what you have to do here, we know the principle of moment, right? So before that, what I will do, I will find the magnitude of this support, and let us assume this is at D point, so this is RD. So summation of Fy is equals to, downward I generally take negative, upward I take positive. So minus 60, minus 100, all are downward, minus 80. So this is what, minus total 240 Newton. So this is the summation of Fy. Now to support this beam, the RD should be upward. Why? Because the summation of Fy is 240 Newton downward, right? It is downward because negative I have taken downward. But to support this beam, to keep this beam horizontal as per the condition, this RD should be upward. In short, you can say to maintain a equilibrium, or we are trying to find the equilibrant, in short, right? So this RD should be upward, okay, and that is why it should be 240 Newton in magnitude, so that 240 downward and 240 upward should be equal and opposite. I hope it is clear to you, right? Hence we got RD, and that is upward 240 Newton. Now taking moment about B point using the principle of moment, right? We will get with usual sign again. So I generally follow clockwise as positive and anti-clockwise as negative. So let us take moment about B point, right? This point here, I'm just making dark, right? So I will get moment as, I will keep you visible, yeah. So let us take moment, let us start from A point, then from C, and then the moment of this up about B. So moment of 60, it is, you know, anti-clockwise. So minus 60 into perpendicular distance up to B is 6 meter. It is given here in the diagram. So be careful. So it is 6. Then moment of 100 Newton about B. See how it is rotating about B in anti-clockwise fashion. So it is minus 100, distance is 3 meter. Be careful. Then we have moment of RD. So that is upward, right? And it is rotating about B as clockwise. So it is plus 240 into, we don't know the distance, so we are writing X. I hope it is clear. And this should be equals to 0. Summation of moment about a point should be equals to 0 for equilibrium. Okay. Now we can solve this. Just simplify and get the x. Only x is unknown here, right? So minus 60 into 6, it is minus 360, minus 300. I will take this on right hand side, so it will become minus 240x. So it is minus 660 equals to minus 240x. This will get cancelled. So x is equals to 660 divided by 240. Hence x equals to 660 divided by 240, that is 2.75 meter, right? And this is what the expected answer is. Hence, if you see the diagram, this x is 2.75 meter to keep the beam horizontal. I hope it is clear to you. Just practice this problem. Thank you.